Thank you, folks. So my name is Gaurav Chadda, and I'm part of the HeatWave team. You've heard about HeatWave from Nippon, and that's whose team I am in. Today, I'll talk about focusing more on the analytics side and the Lakehouse aspect of HeatWave. So you've heard this before today, and hopefully before as well. HeatWave is a single platform for a wide variety of workloads for data coming from a wide variety of sources. So we include a very mature, full-featured, battle-tested, hardened OLTP database, MySQL. So of course we handle transactional workloads. We have a scale-out cluster, which is HeatWave. It scales to hundreds of nodes, and that we use for analytical workloads. We scale out. It sits on top of a decade plus of state-of-the-art research. We have an integrated and automated machine learning pipeline, and we very recently added generative AI workloads with, again, a lot of automation with very little ML expertise needed from the user, with LLMs running inside the database. And I said, the data can come from a wide variety of sources, right? So the data can, of course, be in your MySQL database. And all these workloads I just talked about run transparently. You don't have to do anything special. It's just whatever queries you run on your existing table, on existing data, get offloaded to this very fast scale-out cluster, which is HeatWave. The data can come from files, and as the data is growing, right, more and more the users and the industry is choosing to put the data not in a transactional database, but as files in a data lake. And the advantages are manifold, as we'll get into this presentation. Why should you choose HeatWave for analytics, right? It's the lowest cost, it's the best price performance. And compared to the industry and the competitors, it's not 10% faster, it's not 40% better. It's 23 times faster than Redshift. It's 27x better than BigQuery. It's 60x better than Databricks. And it's much less expensive. So we have not just improved a little bit, we have moved the boundary in the state of the art with HeatWave. And this is where I was getting at, right? The data can, of course, be in your transactional database. But when your data grows, and it's growing very fast across the industry because of a variety of reasons, right? You have SaaS applications, you have sensors, you have monitoring, you have logs, so on and so forth. Not all of this data belongs or is very valuable enough to be put in an expensive transaction database. So what do you do with them? Typically, you'll put them in a data lake, which is essentially files in an object store, typically. Why is this cost efficient? It's scalable, it's online, it has good access control, so that's one of the good reasons to put it in a data lake. This data in data lake, as I just described, is typically non-transactional. It's sourced from big data frameworks, data pipelines, Spark, Kafka, so on. And its usage is growing very rapidly in many industries, logistics, shipping, fintech, and so on. So what opportunities exist here, right? When the data is in your database, everybody knows how to query it. You write some SQL, you write some Python connectors, and you can query it, and the database will do a good job. That's the field that's been going on for decades. Now, when your data is in data lakes, and as I said, there are good reasons to put them in data lakes, what do you do? How do you derive insights from it? How do you derive business value out of it? And that's the opportunity we have with the Lakehouse architecture, which can help you analyze that data at scale in a performant and efficient manner. Also, when you put data in data lakes, it's open to other tools and applications. It's not just proprietary, it's not tied down to that database or that query engine. And that's what we strive to do here with HeatWave, and specifically HeatWave Lakehouse, right? As I said, the data can come from multiple sources, enterprise applications, sensors, even other database exports. You can export the data out of other databases and put them in a data lake, primarily object store. And that can be ingested at scale with high performance and throughput into a HeatWave Lakehouse table and support any kind of querying on top of it. You can build SQL, JavaScript, machine learning, and generative AI applications on it. You can process 0.5 terabyte of data on hundreds of nodes at high performance. And this data that is in data lake, right? When you ingest it for querying, it's not that we are putting this in a database. The data, the source of truth, remains in data lake, remains in control of the user. We provide an efficient, fast, secure query processing mechanism on top of it. And of course, new files will come in. Your Kafka stream will produce new files. Your maybe another data source gets added to your data pipeline or your data architecture. So those new changes and new files need to be reflected in your data that you're querying, right? The data has to be fresh. You don't want results from yesterday or day before. You want results from data that is current. So that pipeline also exists very well and runs incrementally to make it very fast. And any application you've written for MySQL just runs without changes. It's fully MySQL syntax compliant. All of this that I just said works across data in data lakes and databases. And that's the power of HeatWave. It's a hybrid transaction system where, along with machine learning, generative AI, and the same queries, the same workloads run across data, no matter where it's coming from. So why should you choose HeatWave? In addition to all the capabilities, if that is not enough, I guess I should point out it is the best performance and price performance in the industry. The data does not have to be copied. The source of truth remains under the control of the user, and that's very important. Other tools and applications you're writing can query that data. It's not locked down. You can run these workloads, you can aggregate, you can join, you can enhance your data across different sources, across transactional and across data lakes. The generative AI and auto ML workloads run just as they would, regardless of where the data comes from. And it's not a one-trick pony. It can run on multiple clouds. So you can take this compute of this system to where your data is, not do the heavy lifting of putting this data somewhere else. Data is like gravity. It's the hardest thing to move. It's the most expensive to move. It's the most expensive to secure. It's much easier to move your compute where your data is. If you don't take my word for it, here are some results run by a third party on standard benchmarks. These are not something we cooked up. This is TPCH or TPCH-like. For 0.5 petabyte of data, TPCH type, we see both advantages with respect to the competition on loading speed as well as query speed, right? So very often a database will have to make a choice or a trade-off. Do I speed up loading but then do more work during query time so that query performance suffers, or I do more work during load time so your load becomes slower but then your query benefits because you've done the heavy lifting during load. With HeatWave, you get the best of both worlds compared to the competition. Our load is multiple times faster and our query is also multiple times faster, and it is better value for money. It is better price performance. And this, compared to the first slide or the second slide I showed, that was for a smaller data set. This is for a much larger data set. It's the 50 times larger data set. You can see our advantage scales with the size of data. So no matter what size of data you bring in, you will not lose with HeatWave. So let's talk about some real world use cases that are enabled, that we've seen in the field that HeatWave solves extremely well. So here's an example of a banking customer. They have, in a bank, you definitely need a high performance transaction system. Your balance cannot be wrong, no matter how many updates coming in. However, as the bank grows, as the number of customers grow, as the number of years grow, more and more data gets collected. And keeping all of that data in a transaction system or in a transaction database will necessarily or inevitably slow down your primary transaction system. So as well as it will increase your cost. So very often, these banks will offload older data that they're not required to keep, or they don't want to keep because that's not the feature they provide, into some data lake, into object store, which is great, and they have to keep it for multiple purposes. However, how do you then provide value on that data that you have offloaded or removed from a transaction system? And that's a big challenge. This is the data that grows and grows and grows with time and with number of users. And you want to be able to provide historical analysis. You want to do predictive analysis. And for all of these insights and analysis, you need more data than you have in your transaction system. And that's where HeatWave Lakehouse comes in, right? You offloaded your data, older data, into to a data lake or object store. You can load this into a HeatWave Lakehouse or create a HeatWave Lakehouse table on top of it. And then you can run the analytical queries. You can run the machine learning queries and essentially unlock more value out of your dormant data that was not there before. Another example. This is from the telecommunications industry, right? A telecom operator collects a lot of data, user records, their network performance, their network tower performance, so on and so forth, CDR records. And again, this is a lot of data, not necessarily needed in a transaction system. So that also goes on a data lake. Again, how do we enable insights from these CDR records? You load into a Lakehouse table, right? And you can obviously get trends, you can get insights, as well as you can run machine learning workloads to predict network faults and take corrective action before the fault happens. This is highly valuable to prevent loss of service, interruption in service. One more. As I said, data lakes and the usage of them is growing very rapidly in the logistics industry as well. So this is an example of a potential customer from the shipping industry. These ships, I mean, they're large and they're loaded full of sensors. And all these sensors will collect data every second, every few seconds, every minute, and keep pushing it out into files. These files, again, can be loaded into a Lakehouse table and be able to provide insights on it. What is the kind of questions you want to ask, right? You would might want to enrich the data with some predictive analysis. You might want to do some fleet-wide analysis on it. All of this gets enabled when you're able to load the data into a Lakehouse table and allow all kinds of workloads to run on this very large volume of data. You don't even have writing SQL, writing Python code, writing any code is one way. You can also connect your data analysis tools, your BI tools, Tableau and OAC. And these will work as well because this Lakehouse table, even though the data is coming from files, it is presented to you as a user as a MySQL table with the same syntax. And so a typical workflow could look like that you have files in a data lake. So this is like a screenshot of what OCI Object Store console looks like. You have a bunch of files. You load this into a Lakehouse table, and the front end could be a dashboard in Tableau or OAC and other systems. Let's plug this technology into even a larger data ecosystem. So let's say you have events coming from, well, it could come from a lot of different sources. It could come from IoT event sensors. It could come from data pipelines. Or it could be events from object store. I mean, there could be any number of events coming from different sources. And these events end up dumping data to the raw layer of data, which is in object store. You can run an hourly aggregation job and promote this data, aggregate some of it, clean it up a little bit and upgrade it to a silver zone, what we call it, again in object store. Your data could also come from batch aggregation jobs, not just from real-time events, from some asset management, some other tools. And that could be integrated by using OCI connectors and be pushed directly into HeatWave. And once it's in HeatWave, whether it's coming from object store or it's coming from the database, all kinds of analytics and BI tools work out of the box. You can connect this to a data catalog. You can see not just where your tables, but also where the data is coming from. And once the data is in HeatWave, it's a large cluster. It can go to hundreds of nodes. You can run queries to enhance the data. You can run machine learning workloads. You can combine this data coming from different sources and add attributes to it. And once you and essentially promote this into even more enriched aggregated data form, which we call the gold layer. So the entire life cycle of the data, no matter where it's coming from, once it's in the data lake, the object store, it can be loaded into HeatWave. It can be enriched in HeatWave. It can be combined with more data in HeatWave, and this data can be connected to dashboards, BI tools, data catalogs, and so on and so forth. All right. Now let's go down to one level of more detail. You have files in your data lake, in your object store. A question that might come to anyone who's worked with SQL is, data in databases have structure. They have a schema. But files are just files. I mean, they may have structure within the files, but looking at the files, you don't know. And when you want to load or you want to be able to query the data, you have to define a structure on the files. And that is fine if there's one file, there are 10 files, there are even 50 files, you can look at them and look at the schema, create a table, that's fine. When there are hundreds of thousands, millions, hundreds of millions of files, that is a much, much harder job, right? And that's where we have implemented a new technology to automatically infer the schema of the files that is present in a data lake. The way we do it is we don't necessarily have to look at all the data, right? We will adaptively sample your data, infer a schema, so we have a very fast schema inference pipeline, and we'll keep adding more samples to the schema inference pipeline until the schema stabilizes. Once it stabilizes, we know we have something good enough, we have pretty high confidence, and we end up with a schema that is automatically inferred. So you as a user, you point your Lakehouse table definition to your bucket and let the load command do everything. Infer the schema, create a table, create the database if the database does not exist, and load it. At the end of that, one short single command, you have your data available for querying with no hand-holding really. And we support a bunch of formats. These are the most common formats available. CSV, very popular in the machine learning world. Parquet, very popular in the big data framework, in the analytics world. Avro, very, very popular serialization format. NDJSON, extremely popular in the semi-structured world. And of course, exports from other databases, as I had mentioned earlier. We support the full set of functionality on all of these very common formats. Of course, we're adding more as time goes by. What we have worked very hard to do is no matter where data is coming from, in what format, the performance of loading and the performance of querying that data does not change. And why is that important? This allows the user to define the data, or store the data in the format that suits their workflow, their data pipeline best, and not defined by what are the capabilities of HeatWave. HeatWave's capabilities remain uniform no matter what the data format is. And we do this pretty fast. I mean, another benchmark, not to throw another benchmark at you, but we do this extremely fast as well. I talked about that we can incrementally apply changes to data lake to HeatWave Lakehouse tables. Again, going one level deeper for the database folks here, the data in the Lakehouse table is a one-to-one mapping to the data in the files and object store. So any changes that happens in the data lake happen at a file level granularity. You can add files, remove files, update files. And once you are done updating your files, you can control when you want to update your table. So because the paradigm to understand here is that the data lake is the source of truth and is in control of full control of the user. So the user can make the changes to data lake independently, and when they're full and happy with it, they can run another simple command, and that will figure out automatically what has changed, what has not changed, what has been removed, and apply those changes to the Lakehouse table. Data remains fresh. There can be other use cases where you don't want to do this manually, where you want the freshest data as quickly as possible. And for that, we have an auto refresh or an auto load pipeline. It relies on events that are generated by object store or a data lake. Essentially, for each change, each object added, each object removed, an event is generated, which HeatWave subscribes to and updates its table immediately or as soon as possible. One important capability we added was that HeatWave supports, as I said, a wide variety of workloads, right? A wide variety of analytical operators and operations, machine learning, generative AI, so on and so forth. So you have a very rich set of operators and workflows to combine your data, filter your data, enhance your data, aggregate your data, so on and so forth. But once you've done that, you might still end up with terabytes of data because the cluster can be very large, your workload can be very large. So with terabytes of data, what do you do with it? With this new capability, you can export it, that enriched, enhanced, aggregated data back out to the data lake. And this helps you, it's a building block for building a medallion architecture on your data lakes. So switching gears a little bit. We talked about this last year. We talked about, I think this time as well, we'll talk about it more. In MySQL and HeatWave, we added a new data type called vectors. We've added an integrated and automated pipeline to create a vector store out of unstructured data. So you have PDF files, Word files, Excel files, HTML, so on and so forth. This is not structured data. This is not a CSV. This is not a Parquet file. This is completely unstructured data. And there's a powerful way to query it, which is using semantic search, also called vector search. But one prerequisite for that is to create a vector store or create embeddings out of this unstructured data. So we've added the capability to create a vector store. This is, once again, true to fashion. It's a single command. You point to the data, to unstructured data, and we figure out what kind of data it is, how to extract the text, the data out of it, how to chunk it, what embedding model to use, so on and so forth, lots of specifics. No machine learning expertise is required from the user. It's a single command, and we make good default choices using in HeatWave embedding models. So the data is not shipped out. Unlike many other systems, there is in HeatWave embedding models, machine learning embedding models, which we use to create embeddings. Now, once the vector store is created, you might have new documents, and that will also get ingested. You might have removed documents that they will get removed from the vector store. So it's a table in a database, and all the niceties of a database with change propagation, everything applies here. Once you have the vector store, you want to be able to run vector search queries, right? These are what are called distance queries. What they do is to figure out the distance or the similarity between the input and the input text and the text in the PDF, for instance. And that, again, true to fashion, HeatWave scales out over the entire cluster and is class leading in its performance. So what do you do with the vector store, right? Now this is where the power of HeatWave and its support for a wide variety of workloads really comes in and really shines. You can, of course, run a vector search query. Now, this vector search query is down in the depths of details where you take an embedding or a vector from the input query and compare with the vectors you've created. I mean, it's a lot of details to understand, right? But what you can do is call a high-level API that we have created. We call it RAG. Essentially, you ask a question. You want to ask a question of your data in your PDFs, right? Let's say you have the MySQL HeatWave documentation. You want to ask, okay, does MySQL HeatWave support this? Or does it support vectors? Which version does it support vectors? You want answers to these questions. These are very unstructured questions being asked of unstructured data in documents, in HTML, PDF documents. With this end-to-end integrated pipeline of creating vector store and the single commands of RAG, you can do all this without knowing anything really about what machine learning is, what generative AI is. That's one aspect. Second aspect, you can combine this powerful capability of asking natural language questions of unstructured data with our excellent and integrated automated machine learning pipelines. So one example given in this slide is you can get a restaurant name suggestion from our recommender system. Once you have that, you can figure out using the RAG pipeline and LLMs which dishes do you think you would like best in that restaurant. And the value of this is the front-end recommender system pipeline can narrow down the results very quickly and give you a filtered result to feed to the LLM. If you start from the beginning and go towards the end, what you end up with is a natural language question you asked, and you get a response in natural language saying, this is the restaurant we think you like most, and these are dishes you think you like most. All of this is gleaned from restaurant menus, online listings. There's no structured data here that the user ever has to input. If you want to build your own application, then that's the bottom part of the slide, right? You can combine this powerful new way of searching through data with the traditional structured SQL way. You can join this data and build your own powerful applications. An example is you could say, okay, what courses what advanced calculus courses are offered at this university on Monday from 3 p.m. to 5 p.m. This question is really a combination of structured query on the schedule plus an unstructured natural language question on what is the course content. And that can be done using join operators and vector store search in HeatWave. I have some examples of the commands I just spoke about. Creation of vector store is a single command. Querying is a simple distance function. And inputting a natural language question and getting a natural language response is also a single command. Another example, you could have an employee assistant based on contracts. So let's say you are a legal firm. You have a bunch of contracts in PDF, and you want to ask questions of details of the contracts. How do you do this? You ingest all these documents into a vector store, single command to do that. You ask questions in natural language using the other RAG API, another single command. In these two commands, you can build an end-to-end high-level workflow with no knowledge of machine learning, with no knowledge or integration required from your part. It all comes with HeatWave and executed within HeatWave, shipped as one product. With that, I'll just remind you what the promise of HeatWave and HeatWave Lakehouse holds. The data can come from different sources in different quantities. The workloads can come from different domains and verticals. The sizes of the data can be very different, from gigabytes to hundreds of terabytes of data. And we are we strive and we are able to handle all of it in one single system. With that, I'll leave you with some references, and thank you for attention.